Hi everyone, I'm Brandy, an OpenSciEd educator and professional learning facilitator. Welcome to OpenSciEd Chemistry, Unit 1, Lesson 11. This is an important lesson where our students will plan and conduct an investigation to measure how heat and mass are related. We'll consider how our results might help us address the glacier melt and sea level rise. Let's take a look at how we got here. So during lesson 10, we figured out that energy is conserved, it flows between objects, but it's not created or destroyed. Heat transfer, or Q, into or out of a substance can be found by multiplying the specific heat, mass, and temperature change. So in this lesson, we're wondering, how does heat affect the amount of ice melt? Here's the lesson at a glance. This is a one-day lesson where students will plan and conduct an investigation in which they measure both the temperature change of the water and the mass change of the melting ice. In this lesson, we reflect on where our new heat equation fits into the energy transfer model, and we realize that we don't know what affects the amount of ice will melt other than the incoming heat. So we plan and conduct an investigation in which we are going to measure both the temperature change of the water and the mass change of the melting ice. We figure out from the slope of a best fit line of the data that 80 calories of energy are required to melt 1 gram of ice. We now have the information that we need to figure out how much energy transfer a berm prevents as we consider the berm proposed solution. We figured out that because energy is conserved, the heat transfers out of the water from the investigation and flows into our ice. And we also figured out that 80 calories of energy are required to melt 1 gram of ice, Q equals 80 M. And now for the key moments. So the key moment in part 1, the students are summarizing our investigation handout and their exit ticket from lesson 10. They'll reference those during the navigation discussion. You'll draw on this information so that you can make an energy transfer diagram to help your students make a connection back to the equation that we developed at the end of lesson 10. The key takeaway is because the energy is conserved, the heat that transfers out of the water in our investigation flows to the ice. For the key moment in part 5, this is where you will be constructing the best fit line for the students. The slope of the line should be about 80 calories per gram, and it's completely acceptable to use the value that the students derive, not the published value of 80. I found that my students were totally fine appreciating how close we actually were to the accepted value. When you're done, you'll add that equation, Q equals 80M, as key idea number 6 at the bottom of the key idea chart that you started in lesson 10. So where do we go from here? We have the information that we need to figure out how much energy transfer a berm prevents as we consider that proposed solution. So in the next lesson, we'll develop a mathematical model that can help us further evaluate the berm solution. And now for a few tips and tricks. In part 4, this is where the water ice lab takes place. Making ice will take at least 2 days if you don't have access to a large number of ice trays or an ice maker. So make sure you start the process well ahead of time. You'll need to make 2 ice cubes per group times 7 groups per class. So times however many classes that you have. I just bought a cheap bag of ice at the grocery store to save time, and those ice cubes were all about the same size, so it worked great. This lab will probably require more time than the 12 minutes that are listed in the teacher's edition, so plan ahead for that. I set up the 2 styrofoam cups with the lids, the digital scales, and the digital thermometers at every lab station, and then I had a central lab table where I put the water containers that I used. You'll also need to make a copy of the provided Google Sheet for each class, and students will need to add their group's data to that same Google Sheet, and so I share mine through the Google Classroom. There are no new words encountered or co-constructed in this lesson. And for poster management, you'll just need that key ideas chart that you started in lesson 10, so you can add another key idea to the bottom. So to recap, in this lesson, the students reflect on where our new heat equation fits into our energy transfer model. We realize that we do not know what affects the amount of ice melt other than incoming heat. So we plan and conduct an investigation in which we measure both the temperature change of the water and the mass change of the melting ice. Through this lesson, they now understand from the slope of the best fit line of the data that the 80 calories of energy are required to melt 1 gram of ice. Up next in lesson 12, the students will develop a gotta have it checklist and a mathematical model that can help them further evaluate the berm solution. We will use the model to calculate the berm's impact on ice melt. We will brainstorm ideas for an expanded computational model that includes the Earth system beyond the glacier. Good luck and have fun.